Teachers will become familiar with differentiated instruction as modeled in a math demonstration lesson on the fundamental counting principle.
We're going to model a demo lesson that was actually taken from the Right Path Abbott training, and we're using this lesson with permission, but only if we have an opportunity to advertise the fall path trainings that are coming up. So as you can see on this screen, there's going to be path training September 30th and October 1st at the Riverside County Office of Education Conference Center. There's the a website there, SBCSS, where you can access information. So if you're really interested in taking this demo lesson further and seeing what else Abbott has to offer as far as MathPath, please let your principals know and contact this email. So let's do this demo lesson together. So the first thing that your students enter and the bell rings is you want them to do some bell work. So we're going to ask that you play along as students and do this bell work. After we stop this slide, you could always pause and work this bell work out as long as you need to, and then move on to the next, and do that for all the slides. So and then in our bell work, we want you to find the prime factorizations of each of these numbers. So this is not a multiple choice option. We'd like for you to find the prime factorizations of 20, 30, 36, and 98. So let's differentiate instruction a bit, and one of the best tools that you can use to capture more of your students is to have them do Cornell note taking, and I'm sure many of you, if not all, are already familiar with it, but we would like for you to set up a page, a blank page for Cornell note style. So that means a 2-inch margin where you're going to eventually add study questions, a place at the top of the page for an essential question, which is going to come up in a bit, and our topic for today is the fundamental counting principle. Okay, so we want you to add this essential question. How many factors does 2 to the 9th times 3 to the 7th times 5 to the 5 have? And we're going to answer that question by the end of our lesson today. And in all of our lessons, to capture as many learners as possible, we want to start with our vocab. So we have a list of vocabulary words here. I'd like for you to copy these down in your notes, and again, you can hit pause and take as long as you need, and then move on with the rest of the presentation.
Okay, now that you have your vocabulary words, we would like you to put these symbols next to each word according to your comfort level. We'd like you to put a small flower. If I am not comfortable with the word, I'm just developing an understanding and gathering information. Put a tree next to the word that you know something about it. I think I have a good information about it. I am climbing higher, but I need more practice with it. A star means I know the word, I can use it in talking about math concepts, and I can explain it to others. I have reached the stars.
So here are the words again. Just hit pause, take as long as you need, and add those symbols.
Okay, now we're going to do a quick write. Without using any calculations, describe why 2 to the 12th power is much larger than 12 to the 2nd power, or 12 squared.
Now, another thing that we can do to differentiate instruction is sentence frames, and I'm sure many of you are already familiar with them. So we're going to practice some sentence frames together over the next few slides. Here's our first. The factors of blank are blank. So as the teacher, you could fill in the blanks. You could say the factors of 4 are 1, 2, and 4, and see if your students agree or disagree. And you could also go around the room and have the students pick different numbers and say all of their factors out loud. But the main key is to have each student read the entire sentence frame, filling in the appropriate numbers, and have the rest of the class put thumbs up if they agree or thumbs down if they do not agree. So here's another sentence frame that's already filled out. The factors of 10 are 1, 2, 5, and 10. And what I do when I teach this is I put my hands to my chest. When I say the word or say the sentence frame, I would say, and I cross my hands or cross my arms and say the factors of 10 are 1, 2, 5, and 10. And then I would put out my arms to the class and ask the entire class to repeat what I just said. So folding my arms, the factors of 10 are 1, 2, 5, and 10. Holding out my hands, the entire class repeats. The factors of 10 are 1, 2, 5, and 10. You should notice we are building that same vocabulary that we had the students attempt to define and use the symbols for. So here's the next sentence frame using prime factors. The prime factors of 4 is only 2. And the students would then put thumbs up if they agree or thumbs down if they don't. Here's one already filled out, and again we're getting the entire class to repeat the sentence frame along with us. So I would say with my arms folded, the prime factors of 10 are 2 and 5, and then I'd hold my arms out and the entire class would repeat. The prime factors of 10 are 2 and 5. Okay, and then next we would have the students, or I would ask the students to list the factors of 20. So that would be my statement for the class, and then give the students a couple of minutes to write out the factors of 20 as you can see at the bottom of the slide. 1, 2, 4, 5, 10, and 20. And then to make sure to point out that 20 has 6 factors. Then my next question for the class would be, what are the prime factors of 20? And again, they wouldn't see the answers ahead of time, but the prime factors of 20 are 2 and 5, and we would say 20 has only 2 prime factors.
How many ways can 2 and 5 be used to create the factors of 20? If you look at the number 1, you can see that one way is for it's equal to 2 to the 0 power, which is equal to 1, times 5 to the 0 power, which is also equal to 1. 1 times 1 equals 1. As another example, we can see that 2 is made up from 2 to the 1 power, which is equal to 2, times 5 to the 0 power, which is equal to 1. 2 times 1 equals 2. Okay, now pause the tape and finish the rest of the examples for 4, 5, 10, and 20. Okay, now you can check your work to make sure you got the right answers. So now we're going to see how 2 is used. If you notice that the 2 to the 0 power, 2 to the 1 power, and 2 to the squared. So 2 can be used 3 separate ways. Okay, 5 can be used 2 separate ways. 5 to the 0 power and 5 to the 1 power. So we can see that 2 is utilized 3 separate ways to create factors of 20. 2 to the 0 power, 2 to the 1 power, and 2 squared. And 5 can be utilized 2 ways. 5 to the 0 power and 5 to the 1 power. So there are 3 ways to make use of 2, and there are 2 ways to make 5. Okay, so there's 3 ways to use a 2, 2 ways to use a 5, 3 times 2 is 6, and there are 6 factors to make up 20.
So it's also really important to have our students make visual representations of the work that they just did. So one way to visually show these factors and how they work for the factors of 20 is to draw a tree diagram. So as you can see here, we have all the factors of 2, 2 to the 0, 2 to the first, and 2 to the second. And if we picked either of these, each one has 2 ways to use 5, either 5 to the 0 or 5 to the 1. And if you follow the tree diagram from the left to the right, you'll see 2 to the 0 times 5 to the 0 will give us our first factor of 20, which is 1. And we could do that for each branch of the tree diagram to get all 6 factors of 20. So let's pause the tape and follow the tree diagram and fill in each of the boxes.
So here's a short activity utilizing the concepts we just went over. How many kinds of pizzas can be created with 3 meats? Pepperoni, seafood, and ground beef. Or the 4th option would be none. 2 veggies, mushrooms or olives, or again none, and 1 cheese, cheese or no cheese. No doubling up, no meat, no veggies, and no cheese counts as a choice. There are 4 meats times 3 veggies times 2 cheeses, which gives me 24 different combinations. Okay, now work with a partner to construct a visual in your notes that would represent this problem. Okay, let's return to the essential question. How many factors does 2 to the 9th times 3 to the 7th times 5 to the 5th power have? A, 30, B, 315, C, 480, D, 630. Okay, at this point, pause the tape and figure out how many factors does it have. 2 to the 9th times 3 to the 7th times 5 to the 5th. So because a number to the 0 power is also an option, that 9 would change to a 10, the 7 would change to an 8, and the 5 would change to a 6. So you'd multiply 10 times 8 times 6, and that would give you C, 480 as your answer.
So something you could do with your students is put them in pairs or dyads and have them create or exchange other example problems where this fundamental counting principle comes into place, and then have them verify solutions with their table groups or whatever they'd like to do. One place where this is very much used is in public key encryption, our ATM codes. Without understanding of a very large prime number and the fundamental counting principle, it would not be possible for us to use ATM codes with much security security. But having, for instance, my ATM code has 4 digits, so there are so many different possibilities for my ATM code that if someone were to find my card, and knowing that that ATM machine is only going to give them 3 opportunities to find the right code, the odds of them actually finding my ATM code without looking over my shoulder and seeing it ahead of time are next to none. So considering that we are differentiating instruction for all learners, the next thing we'd have our students do is to write a GIST summary. In the Avid world, GIST stands for Generating Information from Schemata or Text, fancy word, but really these are the 3 things we'd like them to do. So number 1, respond to the essential question. Number 2, maybe list 5 key phrases or words that they put in their notes. That could be the original vocabulary, or it could be something else that was added in the lesson. And then we want them to use those 5 key phrases or words to write a 3 to 5 complete sentence summary, summarizing their notes and answering the essential question. So again, you can stop the tape and do that now. So in this demo lesson, we are hoping that you can see that you can cover standards-based content, something like the fundamental counting principle, while ensuring that students are active and engaged no matter what their level of comfort is with the lesson. And after the summary, we would end this lesson with the ticket out the door, just to make sure that they really understand. So on a sticky note, we tell our students to write out the answer to this question. How many factors does 2 to the 4th times 3 to the 2nd times 5 to the 3rd have? They don't have to put their name on the sticky note. We just want to see how many people in our students in our class really understood. And then on their way to the next class, they could leave it on a parking lot or a community forum or at the back of the class.
Okay, reflection question. How does the prior activity provide access for AEL, special education, and GATE students? Okay, ELD identifiers. Emerging, which would be AELs that they need substantial support. Expanding, AELs that need moderate support. And bridging, AELs that only need light support.
So in our district, and for the academic English learners in our math classes, we believe the focus should be on the content of what they are saying rather than the grammatical structure of how they are saying it. But again, remember in our focus lesson, we had those sentence frames, and sentence frames provide an excellent opportunity for AELs to practice the grammatical structure and to use the academic language in context.
Okay, take 3 minutes to read over the standards. With a partner, answer the following questions. How have these 3 standards been addressed in the prior activity? If they were not addressed, how should they be added to the activity to address them?
All right, so on the same Haiku page where you found this presentation, you should see under Universal Design for Learning video. It's about a 4-minute video. So we would ask that you would pause this presentation, find that video, go watch it, and then come back. So as you've seen in the video, Universal Design for Learning asked for us to provide 3 things for all students to learn better. The first, to provide multiple means of representation. The second, to provide multiple means of action or expression. And the third, to provide multiple means of engagement. So we'd like for you to answer the following question. How have these 3 standards been addressed in the prior activity? And if they were not addressed, what should be added to the activity to better address them? In Haiku also, you should find a link to the California Math Framework on GATE, how to better address learning for our GATE students. And we'd have you start at the bottom of page 1 on that document. So again, pause the tape and go look at that document and then come back. And now that you've looked at the document, you should see that for GATE students, we should vary the amount of depth, pacing, complexity, and novelty of each assignment. So again, we're asking the same question. Did the prior lesson properly address the needs of our GATE students? And if not, what could be added to the lesson to address it further? Now there's another document on Haiku that we'd like for you to look at. It's the RUSD lesson template. So find that, pause the tape, take a look at it. And the one we want you to look at is the sample lesson for 8th grade, Unit 1, which is on representing and combining transformations. And what you're going to see is on the side left-hand margin, you'll see the actual places where either the lesson was something in the lesson addressed the EL learners, something in the lesson addressed our GATE students. And so look for those specifically and see how easy it would be to also add those to any lesson that we teach.
Okay, now pick a topic or lesson and expand to include strategies. And another resource, additional resource on the haiku page, is the UDL presentation.